structure in the middle basically start collapsing, and there will be a time when the pressure in the middle will be so high that it will start the fusion reactor, and that is what the star, the birth of the star. So this is something which is very basic, we all know that. But then what happens is that the birth, when the star take shape, it has many layers, and bigger the star, there are more layers. And the important aspect of the gravity, or a tug of war game which is being played between gravity and the heat which is being produced by this newly formed structure now, is something which is to look for, and that is really the cause of making a black hole. So essentially what happens is, once the life of the star finishes, the energy which is being produced in the core of the star is not sufficient for gravity to squeeze it further, to prevent from the squeezing power, and that is when the death of the star happens, and then the black hole is born. So let's understand that why this happens. I think the simple reason is that once the star becomes just start generating iron atoms, then the iron cannot combine with another iron atom, and that's when it start consuming all the heat which is present in the star, and within a split second star basically dies. And then there are three phases the star can end up into, or three different kind of outcomes from that point. So the whole matter is that essentially the star is formed from a cloud into a lump, into a fusion reactor, and then it dies depending on the size of the star at which it was formed. So there are certain stars which are small, there are certain stars which are average, and there are certain stars which are very big, and depending on the size of the star, the outcome of the star would be. So what are these outcomes? Well, the first outcome, let's talk about the neutron star. I mean, there is an outcome which is much simpler, which will happen for our sun after 10 billion years. Most of the material will burn off, and sun is a smaller star, it is an average star, and therefore it has a certain amount of mass. This mass is not sufficient to create much more complex and higher elements. So once the carbon is generated in the core of the star, that's it, the end of the story for sun, and sun will cease to generate so much energy, and then because the energy is not sufficient to even squeeze it further, it will be called after that something called white dwarf. So it will have it will have a lot of heat, because the core of the sun will become white dwarf, and rest of the outer body will be dissipated into a nebula for future systems to be developed. So the high carbon core will have a lot of electrons in it, and it will retain its heat because of the electron pressure. It will not generate a lot of visible light, but it will generate a lot of energy in other spectrums. So that is with regard to the white dwarf. But more interesting fate exists for a larger star, which is at least 8 times bigger than sun, or between 2 to 8 times bigger than sun. Then the result could create, the end result could create us this body which you see on the screen, and that is called neutron star. Now, what is neutron star? Neutron star is an object which is not more than 20 kilometers long, wide, or when it is a complete round. In fact, scientists say that they are the perfect sphere, because there is so much gravity, they pull everything in the star very close with a lot of energy. So they are very perfect sphere that exist in universe, with absolutely zero irregularities in their structure, and they are entirely made of neutrons. So there is no empty space between electrons and atoms. Everything is made of neutron, and they are very highly dense object, not more than 20 kilometers, as I said, but they are so dense, and they have formed from a larger star. So remember when I told you that if the star is much larger, they will end up into a neutron star. That means the core of the star would be at least 2 to 3 times more massive than the sun. And essentially the core of the star will squeeze down into 20 kilometers sphere, and it will have a mass of at least twice the size of the entire sun, squeezed into 20 kilometers. And that is why they are very extreme objects, and very compact and very heavy. 1 teaspoon of the material of a neutron star will weigh as much as the entire Mount Everest. So you can imagine, how much material is there on the neutron star in a very compact space. And gravity plays gravity creates this kind of a structure, and because of that, this is the second. However, there is a limit, because if for some reason star absorbs more material, then there is a limit which is given by the great Indian scientist Chandrasekhar, and this limit is known as Chandrasekhar limit. And that is, for a neutron star to exist as a neutron star, the mass cannot exceed 2.5 times the mass of sun. That means if the mass is very small, again the neutron star will not be formed. It will become a white dwarf. If the mass is more than 2.5 times the mass of the sun, it will then collapse. Gravity will will be very strong, and the forces exerted by neutrons will not be sufficient for that kind of a body which is heavier than 2.5 times the mass of sun. It will completely collapse into the third category, which is the black hole. Well, the larger stars, which are at least 8 times larger than sun, will always end up in a black hole, because, as I said, if the core is essentially the neutron star, and the white dwarfs and the black holes are the core of these stars which we see shining in our universe in the night sky. So these cores, if they are more massive, then the gravity will basically crush them completely, and if the star is at least 8 times the mass of sun, then it will always, there will be no outcome other than becoming a black hole. So we know, and we have a lot of understanding of science and mathematics, and there are various equations. Using these equations, we know that there are certain limits, and we have also seen them happening in the actual with our experience, that for becoming a white dwarf, what we need, for becoming a neutron star, what is the maximum weight and mass required, and for becoming a black hole, for a stellar sized black hole, how much mass is required. But then, so we know that we have seen this lot of stellar mass black holes which are 8 times the mass of sun to about 15 to 20 times mass of the sun. But then between these and the supermassive black hole, there's a huge gap. And then we suddenly started seeing larger black holes which are millions of times of mass of the sun, and that really created some sort of a paradox, because we don't know what are the processes which are involved in creating these very large, humongous black holes, which are known as supermassive black holes. In fact, there are even a fourth category called ultramassive black holes, which are billions of times of the mass of the sun, which are very, very big. And we know that while we know the processes of how the star collapses into a black hole, we don't know how they got so big. And we also know that based on the current understanding of space-time, we know that our universe is at least 3.8 billion years old. So in 3.8 billion years of time, the time is not sufficient for all these matter to combine and start becoming a ultra giant body like supermassive black hole. So that was an intriguing part. And these supermassive black holes are really huge. I mean, they are many, as I said, it's like millions of times the mass of sun. And there could be And the paradox is that you are not able to see a black hole unless there is some activity going on around it. So there could be these supermassive black holes floating around freely in the universe, outside the galaxies or within our galaxies, but we will not be able to see them if they are there's no activity going on around them. It's very, very difficult, because black holes even absorbs light, so nothing comes out of a black hole, and if nothing comes out, there will be no observation that humans can make. So they are very, very difficult. And but we see these supermassive black holes in the center of every galaxy, and essentially the galaxies are formed because of these supermassive black holes. There is one in the middle of our own home galaxy, which is known as Milky Way, and that is called Sagittarius A star. This is a picture of the Sagittarius A star, which was taken recently, and the estimated weight of the supermassive black hole which exists in our own galaxy is 4.1 million times the mass of sun. So it's a huge, I mean, you can imagine the amount of matter that may be used to create this monster, and we don't understand how they got so big, because based on our current understanding, we know that a star cannot exist, a very big star cannot exist, and if a star exists, it will create a black hole which is going to be at least 8 to 20 times the mass of the sun. And even if these multiple black holes, smaller black holes, combine to form a 4 million times the mass of sun, the age of the universe should be at least 1 trillion years. But we are a very new universe, so people don't understand what is the processes to create these heavy monsters. Also, we do not see anything in between. So from smaller stellar star type black holes and ultra massive black holes, we do not see anything in between. These the supermassive black holes are huge. We don't see anything which is like a black hole which is 100 times the mass of sun, or 200 times mass of sun, or even 1000 times mass of sun. So it is a big mystery that how these black holes became so big, and how many are there. Is it a rule that every galaxy will have only one, or there could be multiple supermassive black holes within one galaxy, and there could be supermassive black holes floating around everywhere in the universe, and we have no way to even examine them and know exactly that there is something which is outside, and a supermassive black hole may not have a galaxy around it. So there are a lot of these intriguing questions around it. And the heaviest supermassive black hole that we have seen, or sort of ultra massive black hole, is called TUN 618, which is estimated to be a huge black hole, 66 billion times the mass of our sun. I mean, you can imagine this small dot you see here is the size of the Earth orbit. And Earth orbit, trust me, is not small. Even Earth is at such a huge distance from the sun that even light takes 8 minutes to reach Earth. So the small dot here in blue is the size of the Earth orbit, and this is the size in comparison of TUN 618. So you can imagine this colossal beast is so huge. And this large black hole has been has been located at 10.8 billion light years from Earth. So it is very far off. But do we know that even bigger black hole exist or lurk around somewhere without our knowledge? So we don't know, and since we don't understand the processes of making these large bodies, so this has been a question ever since Einstein came up with the theory of relativity. Nobody has found a conclusive answer, especially because to examine black hole is very, very difficult, because we have to look at the indirect methods of finding these to locate these black holes. Even small black holes, we need to rely on indirect methods to examine these black holes. And because of these challenges, it's a big question how the black hole became so big, and that is what I'm trying to answer. based on the current understanding of the space-time. Well, scientists now believe that the supermassive black hole may not have come from a star at all. What they believe is that the supermassive black hole would have directly collapsed during the early part of the universe, when universe was very hot and the matter had just formed. The things were very close by. We also know that the space is also expanding. The galaxies are moving apart. We are all moving apart from each other, and this was also proven by Hubble, that the galaxies are moving apart. So considering that, in today's environment we see that there are space which are spread out, but when the universe was formed, then things were very close by. All the material was kind of stuck together, and matter had just formed. So there was more gravity, and there was a lot of material existed, and there was a lot of pressure. So in such conditions, there could be a possibility that the matter directly collapsed, similar to what I showed you in the beginning of the program, that there was a cloud which started rotating and eventually ended up creating one or two stars. Similarly, in the early part of the universe, when things were very hot and very dense, the similar process would have taken place, because gravity always works in the same manner, and because the pressure was high, the star wouldn't have got the time to form. And at that time, when the temperature was also very high, the matter would have collapsed directly into a very huge, at least 300 to 400 times the mass of sun type of black hole, straight away, without forming a star, then white dwarf, then neutron star or black hole. It would have collapsed directly into black hole. And that is what the most plausible theory that we have regarding these ultra massive or supermassive black hole. Otherwise, even though this is not conclusive, but we still believe that this could be one of the reasons. Otherwise, there are no other processes in the universe which can explain formation of these huge monsters and beasts in our space. Now, I have one viewer from Twitch, and this viewer's name is Diggs BTW7, and the viewer is asking, what's up? So I'm fine. Diggs BTW7, thank you for watching my program. If you have any question, feel free to send me a question, and thanks for watching. All right, so let's go back to our discussion. So in the early part of the universe, when things were very close by and universe was very new, the matter had just formed, there could be a chance that these the matter, neutrinos, hydrogen nuclei, they were still, the temperature was quite high. It could have collapsed into a large black holes, at least 200 to 500 times the mass of sun, straight away. And then gradually these large black holes combined to merge together gradually, because things were still close by. There were enough material available in a highly dense early universe, and these black holes were created, and then soon they merged to create these ultra massive black holes that we see when we look around in our space-time. We see these monsters. So that this is one theory which explains that why we see so many ultra massive black holes in the middle of the galaxies, and we do not see anything in between. That means these ultra massive black holes were formed soon after the Big Bang, soon after the matter was formed, and they are very ancient, and then they slowly spread out in the entire universe, and they took a lot of matter which cooled eventually and started forming galaxies. And all other stellar type black holes came later, and by the time, and these stellar type black holes came later, and therefore we do not see anything in between. either we see a smaller black holes or we see these ultramassive black holes. So this could be one of the reasons that we do not see anything in between. So friends, these are something which I wanted to talk to you live today, and probably kind of explain why we do not see we see smaller black holes and we see larger black holes, but we do not see mid-sized black hole, and that is a mystery. I thought I will throw some light based on the recent scientific discoveries. I think we are living in a very exciting time, because now we have the method to even calculate the gravitational waves, and using these gravitational waves we may be able to look inside the black hole, not merely have theoretical model of how black hole functions, but we may also get some inputs from within the from inside the black hole, and probably it will throw some light on the structure that exists inside the black hole. So I think we will wait for such discoveries, and I keep bringing these interesting discoveries. So thanks for watching, friends, today our science show, and I will meet you again next week on Monday. Till then, have a nice weekend and take care.